Okay, so now we're going to look at solving equations. First, we're going to look at the one-step equations, where there's just one algebraic step to solve the equation. So in solving equations, what we really want to look at is we want to find what we don't know. So you're solving something that you don't know initially by looking at it. For example, 2x equals 10. Well, just by looking at it, you'd probably figure out that x has to be 5. Okay? So there are methods for finding that x equals 5. I'm going to show you the algebraic methods. There you can use algetiles and you can use diagrams and stuff, but I'm going to show you the paper and pencil algebraic method. Okay, and you might have something like 2x plus 7 equals 13. How do you solve for then what x is? It's not as obvious in this one, but there's methods for doing that. And you might have something like 5x minus 17 equals 3 times x plus 4. Okay, and how do you solve for x in that one? So what you want to do in solving equations is find the unknown. The unknown is x in these cases. Okay, so x is not a variable because it doesn't change. It is just called an unknown. Okay, so we're going to look at one-step equations. One-step equations. Well, here's some cases here, and we're going to take a look at that. So case 1, well, you have something times x equals something. They're both constants. The c and the d are constants. Now, if you've got c times x, how do you get rid of a times? You divide. So, and in solving equations, there's one main rule. Whatever you do to one side, you must do to the other. So you can't just divide one side by c and keep the other one the same, because then they're not equal anymore. Okay, so you must preserve the equality sign, which means whatever you do to one side, you must do to the other. Okay, so divide both sides by c. And when you do, okay, so divide by c on both sides, you can cancel out the c's, because c divided by c is 1. So it's basically like writing 1x, and 1x is just x. So in this case, when you've got something that looks like cx equals d, x equals d over c. Okay? And you need to show these steps. Case 2, let's take a look at that. When you've got here you've got x over c equals d. Well, now that's x divided by c. If you're going to divide by c here, to get rid of that, to find out what 1x is, then you're going to have to multiply. Multiplying is the opposite of dividing. Right? So multiply both sides by c in this case. And when you do that, you're going to do c times x over c, which is that side, equals c times d, multiplying both sides by c. But on this side, the c's cancel out like they did before. It gives you a 1. c divided by c is 1. And you get x equals c times d. So that's the strategy for that one step. Okay. Another step here is, so case 3, I call it. Well, in this case, you got x plus c equals d. So the other ones were multiply and divide. Now we're going to do add and subtract. So if you've got x plus c equals d, then subtract c from both sides. Right? You want to get x alone here. You want to isolate x. You take that c away, and that gives you 0. Okay? So plus c minus c gives you 0, and then you have d minus c on the other side, and that's your solution for that one. Okay? And case 4, well, it's for the minus. So x minus c equals d. If you got minus c, then you're going to add c to both sides. Just like this, add c to both sides. Negative c plus c gives you 0. Okay, and then you get d plus c on the other side. So that's the process you go through now. So let's do some examples with numbers here. Okay, so the first one is, it was 3x equals 9. Okay, so the first thing we're going to do is divide both sides by 3. Okay, because it was 3x, 3 times x, so we're going to divide by 3 to get rid of it. And then you get x equal to 3. Fairly straightforward. Now, you want to check this. Okay, so you want to make sure this is true. And when you do a check, a formal check, you need to check the left side of the equation and the right side of the equation. You cannot put an equal sign between them until you know that they're equal. Okay, so we're going to look at the left side. The left side is 3x. 3 times 3, because x is 3. And 3 times 3 is 9. Now the right side of the equation was 9. So it's true. We've got it right. The left side equals the right side after we've checked it. Okay. Next example here is we've got negative 5y equals 40. Okay, negative 5y equals 40. So we have to divide here, not by 5, but by negative 5. Okay, we've got to get rid of all that, the negative and the 5. Divide both sides by negative 5. Okay, turns into y equals then negative 8. 40 divided by negative 5 is negative 8. Let's do a check for this. Check. Left side is negative 5y. Plug in the negative 8. Negative 5 times negative 8 is 40, and that is the right side of that equation, 40. Okay. Another example over here. Okay. So we've got z over 11 equals 3. That was the original question. Z over 11 equals 3. Multiply both sides by 11. Okay, to get rid of that divided by 11. When you do that, those cancel out, give you a 1. And you're left with z equals 33. Okay? And the check for this is right here. Check the left side. Z over 11, 33 over 11 equals 3, which equals the right side. Therefore, it's true. 4. Example 4. So in this one, we had negative over negative 3 equals negative 5. In order to solve that, you're going to have to multiply both sides by negative 3 to get rid of the divided by negative 3. Okay, so like that. And when you do that, those cancel out, give you a g. That gives you positive 15. And here is the check for that one. Example 5. Okay. Example 5 is going to be x plus 2 equals 7. So what do you do there to get rid of the 2? You subtract 2 from both sides. So x plus 2 equals 7. Take away 2 from both sides gives you x equals 5. Because 2 minus 2 is 0. That's all you'd have there. Here's a check for that one. X plus 2, 5 plus 2 equals 7, which is the right side. And how about example 6 here? Example 6, negative 5 plus x equals negative 8. So that's a negative 5. That would have been the same as x minus 5. That whole statement there, same as x minus 5. So you're going to do plus 5 on both sides to get rid of that 5. Then you've got x equals negative 3. And here's a check for that.